bonjour. Merci d'être ici à DevOps France. Je peux parler en français, mais you rather not hear me speaking French all the time because then you will laugh and then it's going to be too funny and it's going to be recorded in video. We don't want to do that. So thank you for being here. My name is Carlos Sanchez. I'm going to talk to you about Kubernetes and all the buzzwords you can think of today, probably. If I forget any buzzword, you can tell me at the end of the talk, and we'll talk about that too. I work at CloudBees on the Jenkins project. Probably you all know what CloudBees is because there's like 6 talks from CloudBees employees, or something like that. And that's my Twitter handle. And a little bit about me, so you know where I come from. I spent a number of years working on Apache Maven. And who hates Apache Maven? Yeah. If you love it, don't say anything, or the haters are it's gonna be a fight. And I've been doing a lot of the container-related work on Jenkins on both CloudBees, Kubernetes plugin for Jenkins, and things like that. And I hope you don't like slides, because this is the only slide I have today. Really. So let's start talking about something else. So before I start, who is using Kubernetes today? Raise your hand. Keep your hand up if you're using Kubernetes in production. There's some people that have, like, yeah. Who's using Jenkins? All right. Who's using Jenkins with Kubernetes, on Kubernetes? Okay, some people there. Okay, so there's several ways of running Jenkins on Kubernetes, and there's one particularly new thing that has been launched on the open source side. This is called Jenkins X, which obviously has a great logo, as all the Jenkins-related things. And basically, this is for people that are targeting Kubernetes and doing deployments of Kubernetes, and they want like a very streamlined, very standardized way from moving from Git source code into production with Kubernetes, right? So what does it do? So when you install Jenkins X, you can create your own Kubernetes cluster, so you can do that for you. You get Jenkins, you get Nexus, you get Monocular, which is here, Monocular, sorry, and you get Chart Museum. So you get a private Docker registry. So you get Chart repository, you get a Docker repository, you get an artifact repository, and everything is pre-configured to work together. So basically, this workflow, and I'll show you now an example, takes your source code. It can create Docker files and Helm charts for you using Draft. And it uses a scaffold to build that. And will deploy these charts automatically to your cluster in a very, very nice way. So I have an application running here in one of these tabs somewhere. Not this one. Not this one. Not this one. Okay, maybe not this and this. I have too many Kubernetes clusters running, so it's just hard to figure out where the things are. So it's all about the command line. So JX is the command line application. Can you see that from the back? Yes? Okay. So JX get apps. I have a couple of applications running. Do I have the internet connected? Yes. And I have this Croc Hunter application, and I have deployed this before coming here, just in case the demo doesn't work, you know, things happen. And I have 2 URLs. You will see here a staging URL and a production URL. So if I hit the production URL and remove the S, because yesterday today I got an email from Let's Encrypt saying that I was doing too many requests because there's a bug on Cert Manager. You know that you can run Cert Manager and it will automatically generate Let's Encrypt certificates for you on Kubernetes. So everything you run on Kubernetes, everything I run in this cluster, automatically gets a free SSL certificate for everything I run. So it's great until you hit one bug and then you get an email from an angry Let's Encrypt operator, right? So I have this application running. It's a really very funny game where you are just chasing crocodiles somewhere, with lasers. What could go wrong? Yeah. And I have the code for this in GitHub. Let me order my tabs. So it's a Golang application, nothing really fancy here. And, this is the code. I have crockhunter.go. This just serves an HTML page, nothing important there. So what I've done before, I have imported this on Jenkins X. And Jenkins has started building and deploying this to staging production and so on. So what the flow looks like is, let's say now we get a letter from environmentalist saying, chasing crocodiles with lasers is not really great. Can you do it, more environmentally friendly? By the way, this is a demo that some guys at Microsoft did, the Croc Hunter. So I'm going to change this application. I'm going to change this script here. And OK, let's see. OK, I have this change. And I'm going to say, first, I'm going to commit it. Say no lasers, because this is bad. So I just committed that change. I'm going to raise it a little bit so you can see it at the back. Probably too. Oops. Come on. Okay, not this way. Not this other way. All right. So what I can do is JX, create issue, I think it was. Yes. Do you want yes? My username, use the title. No lasers. OK. So this has automatically, has created a GitHub issue. I can go to GitHub, and I can see my issue here. No lasers. OK, number 13. And I'm going to push this. Oh, shit. I pushed to master. Oh, God. Always things go wrong in the demo. Let's revert it. Let's push it. Let's create a new branch, as everybody should do. No lasers. OK, let's do it again. Let's push it. OK, now it works. All right, so I have this. I use the GitHub command line also here, so you can create a pull request with hub pull request, no lasers, and I forgot to say in the commit, but I'll say it here, fixes number 13, I think it was. Right. OK, so this creates a GitHub pull request, and uses this one here. And in a second, there's some checks happening. So Jenkins has already started building my thing, my pull request. Obviously, there's going to be 2 master builds because I screwed up. So let's show that. Yeah, there's these 2 master things running. There's this one that is the one it matters now. And it's waiting. I'll show you the master one just to see the logs. So Yeah, actually, because I pushed to master, I kind of screwed up the environments, but we'll see that later. So what this has done is, or is doing, is bumping the version number, is creating the Docker image, deploying it, is creating the help chart, deploying it, and this is getting pushed into a staging environment, the master branch. For the PR, it goes to a new environment. So every PR generates a new environment. It's a new Kubernetes namespace, totally isolated. And when this runs, which we'll see here soon, okay, there it is. It's doing something, building and pushing the snapshot. And I have here, this is production. This is this. By the way, another cool thing that we do is we have auto-scaling enabled in these Kubernetes clusters. So it doesn't matter how many things I throw to Kubernetes, it will create more instances as needed and scale down as needed too. So you can do that for different Kubernetes installations. You can do that in AWS. You can do that in Google Container Engine, which is what I'm doing. I'm using here Google Kubernetes Engine. And let's see. Okay, my build has finished, and I get a message saying, PR built and it's available in this preview environment. So I go and click to see this preview environment. You can see here I just added the commit ID. And what the changes I did is instead of throwing lasers, now I'm throwing fish, which is more like animal friendly, right? Crocodile eating fish, of course. So I look at this PR and I say like, okay, this looks good, right? So I do the code review, of course, because I'm not that kind of person that commits directly into master, maybe. And I merge the pull request. And what's going to happen, let's delete the branch. This is going to trigger another pipeline again. And you'll see it here. So this is now an event to master. And what this has done in the past, and I'll show you in a previous pipeline. Okay, this one. So it's automatically promoting, all the master commits automatically get promoted to the staging environments. Jenkins has this concept, native concept of environments. By default, you have development, staging, production, and then you get a free new environment every PR you create. So you can always see what's happening between all the PRs, the staging, and production. I can use the command line. I mean, Jenkins X is a lot about command lines, so I can get the environments. And because the size is big, you won't see it clearly. We have development. We have a staging here. We have production here. We have, for several PRs that I have created, different environments. And if I go and do the get apps again, I can see where my staging environment for Croc Hunter is, which is here. And my staging environment still has the lasers. And once my PR gets, my master build finishes, that's going to become staging automatically. So this is 9-2B commit. This is production. This is the PR. And this will be there in a bit. Still waiting for the run to start. So let's, okay, there it is. So what this has done, it has deployed the chart to Chart Museum, so I can go to Monocular, which is the UI on top of this chart repository. I can see what versions, when have them, were they built, I can get any versions. It's like an artifact for chart repositories, which is basically the package manager for Kubernetes, or the most popular one. So I can take a look at any of them and see what happens. While this is building, the other cool thing that this does, well, it obviously GitHub has closed my issue because it was referenced on the PR as fixes. But if I go and look into releases, and well, I'll show you a previous one because this hasn't finished yet, the build. You get a nice changelog of things that you have fixed already. So JenkinsX will go through the changelog and will go through the issues that have been included in that release and automatically generate the changelog. And it can also do other things like generate a blog post where you can see the changelog in a nicer way and so on. So let's see. Okay, so this is being promoted now to the environments. It uses a lot of native concepts from Kubernetes. It stores the environments that I've shown you and the apps. Those are model objects in Kubernetes. In Kubernetes, you can basically create any type of objects you want, and they get stored like the normal objects, like pods and replica sets and deployments. So this is creating all these new types of models and storing everything into Kubernetes. You can also do things like see the pipeline execution. It was here somewhere. Yeah, you can get the logs of the pods. You can see the pipeline was here somewhere. So X logs, and I think you can see the logs from, for instance, Jenkins. So it's interacting directly with the Kubernetes API, right? So it will show all the things that is screwed up before preparing this demo, all the stack traces. Let's see if this is promoted already, which probably is. So this was 9.2b, and now it's 2.5c, but it's not yet the one I want. Okay, we'll leave it at that and wait for it to finish. It's taking a little bit longer. In the Kubernetes side, I can show you Kubernetes engine, Kubernetes clusters. So this is the cluster where I'm running. I have 3 machines with the workloads. So I'm running, well, a lot of typical things that you would run on a Kubernetes cluster that is included by default. But then you can see here that it's running Jenkins, the Chart Museum, Docker Registry, Hipster, MongoDB, Monocular. All these things are installed for you by JenkinsX. And when you install JenkinsX, you can see a couple of deployments for the PRs that are still around. And I have another app running that does another demo. So how does this work behind the scenes? If I go and show you, let's go to this other server. Yeah. Let's create a new pipeline. Let's call it DevOps. Let's create a pipeline. So let's say I want to run my jobs in agents that run on Kubernetes. So I can define as code how do I want my agents to look like, what containers do I want, what images to use. So I can create a pod template. I can say name is DevOps. And label, let's put it DevOps 2. Maybe bigger. DevOps. DevOps. And I can say containers. And I can pass a list of containers. So by default, I don't need to add any. This will run in a Jenkins agent image. So I can do something like, actually, let's remove this. I can do node, and I can say in the DevOps node, run something like hostname. I think this should be right. Name, label, blah, blah, blah. Save. Build now. So what's gonna do is, okay, it's gonna go and tell Kubernetes, I want a pod that by default, because I didn't add any containers, is gonna have the Jenkins agent. I want this pod with this container. And when this pod comes up, it connects back to Jenkins and says like, oh, I'm an available agent, so you just execute whatever you want in this container. What happens is Jenkins now starts sending the job to the container, and after the job is done, the container and the pod are deleted. So it's all dynamic, everything runs on Kubernetes. So if you have auto-scaling enabled, so this scales absolutely, this just sends things to Kubernetes. And then if you have auto-scaling enabled on Kubernetes, that basically will create as many instances as you want in your cluster. So that worked. It gave me the host name of the pod, but let's make something else, something that you can only do with this Kubernetes plugin, which is defining multiple containers. So I can say containers, and I can say okay, container, template, and I can say, you know, name, Maven, because you love Maven, people love Maven here. Image is the Maven image. Let's use the Alpine version because this is smaller. And I can use two small things that need to be taken into account. When a container dies, the whole pod dies. So you want containers that are long running. Otherwise, your agent pod is just going to start and then crash. So for things that don't have an entry point or don't run any long running process, what you can just do is TTA enabled equals true, and command is cut. So this basically just runs cut and waits for it to finish and never finishes. Now what I can do is, obviously this pod here, I cannot execute Maven because it's a very minimum Docker image that doesn't have anything installed more than the what is needed for the Jenkins agent, which is Java today. But I can say container, Maven, and I can say sh mvn -version. And I can run this. And this is gonna start, and we can see it here. kubectl. Let's see if I'm in the correct namespace. So kube ctl -n here get pods --watch. Yeah. So this is the one that has been just launched. You see it's 5 seconds ago, and you see how it has terminated. So if we look at the logs, you see this now has Maven. This is executing something, and then it's running 2 containers, one for the Jenkins agent, one for Maven, and then I can tell, go into the Maven container, I can execute this thing, Maven. And they all share the workspace, they share some directories, you can mount secrets, you can do everything that you can do on Kubernetes today. For example, if I were to do this afterwards, outside of the container, you will see how this fails. And here, well, you see that the node is terminating, the previous one, and in a second we're going to see the new one spinning up. There it is. It's pending, then container creating, then running. It's all happening. And there you have. Well, agent specification, well, you have the Maven Alpine image. And you see that the first Maven invocation succeeded, the second one failed because Maven is not installed. So you just gotta be careful where you execute things. But this has the enormous advantage that you can just mix and match any images that you have in the Docker Hub. You don't have to create, the other option is to create a big image with everything you need, with Java, with Node, with Go, with all these things. You don't have to do that anymore. You can just choose the right images you want. Now, if I were to have another example that shows this, so this would be multi-container. In this example, I'm going to show it here. It's going to be more clear. Multi-container. So this would be a template that has a Maven and a Golang containers. So I can do both a Maven build and a Go build in the same agent, but reusing all the Docker Hub images. I don't have to touch anything. I don't have to create another image or do anything like that. I just define this, I'm done. So this basically goes into the Maven container, executes Maven package, goes into the Go container, and that's a make build. And that you'll see it here. Right, agent specification is Maven and Golang. And now it's doing the Maven package, and then we'll do the Golang makefile. So, well, first it's going to download the internet, and then it will do whatever you want. So I'll leave it here running for 15 minutes. Now you say, well, I'm not going to build Maven and Golang things at the same time. It's just a stupid example. Yeah. So I have another example for people that are more familiar with Selenium. And actually, I'm going to show you. You guys know what Blue Ocean is? It's the new UI for Jenkins. It doesn't look like it's from the 90s. So I have this Selenium build example here. I'm going to just run it again. It's free. So what this example does is it creates an agent with 6 different containers inside the pod. It has the Jenkins agent that you always need. It has 2 Maven containers. Let's show it here. It has 2 Maven containers, one to do a build test, a test in Firefox, one to do a test in Chrome. Then it runs another container to do a Selenium hub, and 2 other containers, one for Selenium in Chrome, one for Selenium in Firefox, okay? So it's 1, 2, 3, 4, 5, plus the required Jenkins agent one. Now, why would I do this? So I can run in parallel, and I'll explain later while all these options are here. What I can run in parallel is 2 Maven builds, right? One that targets or tests against Firefox, one that tests against Chrome. And you can see that here, that these 2 things run in parallel. And at the end, I can get the logs from the containers just to show how to do that. But these 2 things are running in parallel. Let's see if the other one is running here. Well, it's not starting yet. The test for Chrome, the test for Firefox, everything running in parallel. Imagine that you want to do something similar with a database, right? You want to run some test against a database. You can use the MySQL container, a Maven container, and run the test in one pod, in the same pod. So you don't have to have any external database or anything like that. Now, all these strange numbers that you see here is that if all these environment variables is just a technicality of how the Selenium images are built, how they provide them. They basically provide them to run them as Docker Compose easily. But what happens is in Kubernetes, everything that runs in a pod share the networking namespace. So if you have two containers trying to open in the same port, they're going to collide. So what I'm saying here is just connect to the, and also there's a parameter to what hub to connect to. So I'm saying connect to the hub in localhost because everything in the pod is localhost, can be connected to each other as localhost. And I'm saying use a different port for Chrome and use a different port for Firefox so they don't collide with each other. That's just a matter of how to configure things. Now, there's also support for Jenkins Declarative. Who's using Jenkins Declarative Pipelines? Nobody. Well, 3 people, 4. Very shy people. So you can also do declarative is this like simpler syntax. So you can also define Kubernetes agents with declarative. Similarly done before, you define what container template to use, and you just run things inside that container. So it's just simpler. It doesn't have all the full Groovy language pipelines, which is good. It's also a bad thing because then you have all the Groovy things available to you, and people tend to do a mess of that. But it's you have both ways of defining the pipelines. And one thing that recently was implemented is the ability of using just the normal Kubernetes syntax. And so if I were to run the same job or the same pipeline I was running before, I can define it as a YAML file. That would be the normal Kubernetes syntax. Why would I do this? Well, there's just because Kubernetes is adding features and there's a lot of different features and configuration, and this allows you to just here, this is the YAML, just send it to Kubernetes. So you can use whatever feature of Kubernetes, whatever parameter they define, whatever new YAML option they define. And it's some people find it easier to just say, no, I want to keep these things on Kubernetes syntax, the Kubernetes things with Kubernetes syntax, the Jenkins things with Jenkins syntax. And you can have here the same definition, so you can have multiple containers running and so on. Other things that you can do is mount volumes. In this example, what I'm doing is instead of downloading every time from the internet my local Maven cache, I can have a persistent volume that I call Maven repo. You can use persistent volume claims. You can use EBS volumes, Google Disk, NFS, whatever you want. And I'm saying, okay, in the Maven container, mount this volume into the .m2 repository. So it doesn't have to download it every time. It's already cached there. The volume gets mounted when the pod starts. Maven runs, doesn't have to download everything. Now, this must be used with caution because it's not really a lot faster than downloading from a local proxy. And what this makes is it prevents, because read-write volumes cannot typically be attached to more than one pod at the same time or more than one host. So if you are trying to start 2 pods that want the same volume into different machines, if Kubernetes tries to do that, this one is going to wait until this one unlocks the disk. So it may have some advantages depending on the use case, but you can do that. So again, you can define anything you want on Kubernetes. You can define pod affinity if you want one agent to run on a specific host, or taints, tolerations, everything that Kubernetes provides. And so let's see here. And one thing that we are doing at CloudBees, let's see. And this would be on the more commercial side. So use Kubernetes to run our Cloud-based Jenkins Enterprise product. So basically, we run everything, masters and agents. I was showing you mostly agents, although I'm running also the masters on Kubernetes. With CJE, what we call it, we have built it so everything runs on Kubernetes. We have this operation center, which is the UI you see here. So I can go and create a new team. Let's call it DevOps. I can choose a team icon, permissions. I can have, there's some recipes that on what plugins you want to have installed, and I create the team. What this is doing behind the scenes is creating a Jenkins master for you, pre-configure with Kubernetes agent, automatic dynamic execution. So everything runs on Kubernetes, and I can show you here. So let's switch cluster. Get all. Yeah, wrong cluster, as usual. So we run here. I have 4 stateful sets running Jenkins, one for Operations Center, one for each of the teams I have in my Operations Center. So these are Jenkins master with the specific plugins installed. And you see the pod started running, and this is the one I just launched. So it's launched in like really no time. And I expose this through ingresses and the Nginx ingress controller. So you get all these, well, this is gonna finish in a second. But if I go to one, the one that already exists, this is using the same DNS. It's using Nginx to do the proxying through Kubernetes and going into the different services that I have running. So with that, I lied to you. I did have one more slide. So I think it's time for questions if you have. Yes. You can install Jenkins X in, yeah, you can install a Jenkins X wherever you want. If you go here to the quick start, so you can download the CLI. You can create clusters on Google, Amazon, Azure, and Minikube locally. And this would create a new Kubernetes cluster for you, right? Yeah, right now it's very streamlined to be this standardized workflow, and it would be in the same cluster. Yes. Well, it uses its own namespaces. So it uses Kubernetes namespaces to split where Jenkins runs, where Jenkins X runs, where production runs, where staging runs, so it has this concept of environments today. I mean, it has been announced like a month ago or something like that. So it's for people building applications to deploy into Kubernetes and following this model of I use one Kubernetes cluster and deploy everything there. And I use Kubernetes features to do isolation and permissions and so on. You could have
if you have one cluster for development and one cluster for production?
If we have one cluster for development, one cluster for production.
Yes, we can't use Jenkins.
Not today, not today. You cannot do that today. Jenkins X today is for you run on one cluster and you use namespaces for splitting things. Okay. Yes. More questions in French, in English? Spanish? Yeah?
You have previously shown an example in which you have parallel builds for two Maven builds.
Two parallel builds of Maven, yes.
What about the workspace and the checkout of the project?
Okay. So what about the workspace and checkout of the project when you have parallel builds? So the smart thing that the Kubernetes plugin does is it mounts the same, it mounts a new volume, empty volume, across all containers. So all containers are sharing the workspace. All containers in the pod share the workspace. So when you do a git checkout and you execute things in any of the other containers, all those containers can see the workspace.
Okay, but then if you have actions that collide.
If you have actions that collide.
Two Maven builds parallel
Yes.
in the same project can collide.
If you have two Maven builds parallel in the same project, in the same files, yeah, they may collide. So it's up to you if to not do that, because why would you do them? This would be to do them in parallel in the same pod. So you could have different pipelines running in parallel. So this would be for things that share something, right? That you want to run in parallel, but sharing something, right? Like sharing the database, or sharing the Selenium instance, or sharing something. If you don't want to share anything, you just do two different pipelines. Yeah. More questions? Otherwise, I'll be at, yeah.
Can you choose another hosting
Hosting
source code than GitHub?
in a different place than GitHub. Yes, there is. I think there's support for Bitbucket and normal Git, but I'm not sure because that has been recently added. I can get back to you with that. I don't know which ones have been added. Initially, it was just GitHub. I know in the last weeks there's been something else, Bitbucket and another one that I don't remember. Yeah. Hmm? Possibly, yes. There's all these docs here. I went through how to import projects, and you can import an existing project. You can create a new quick start on Jenkins X, and create a new Golang project, a new Node project, Java. So it's easy to streamline the start and the deployment on the continuous delivery part. More questions? Yeah. Yes. Jira, you said? If it can work with Jira, right? I think there is work in progress if it's not done yet. Let me see if I lied to you and this is not, I didn't even show you how to promote things. Is this staging? All right, yay. And now the last thing I'm gonna do is JX JX promote. No, JX apps. No, get up. JX, wait, I'm in the wrong place. Cube, CTX. Too many clusters, don't do this. Don't do this at home. JX, get apps. And JX promote, and I want env is production, and version is 00. You can see that in production I have 0017, and in staging I have 0020, and by default production is set to manual promotion. So staging is always up to date with master. Production, you just decide whenever you want to move things to production. And this is basically what I'm doing right now. I'm saying, that, yeah, I like what is in staging. Just send it to production. And it will do all that for you. And then production will get updated. So if you don't have any more questions, I'll be at the CloudBees booth at the entrance. And you can talk to me then. Merci.